Okay, great. Mm, well, since there are some issues happening on the network these days, I will maybe won't be running the camera because anyways, it will be camera plus the screen sharing, so it's a huge data. Okay, so yeah, so we started with the question. Okay, yes, Benes, you can ask a question. Okay, what you need to do because you can't do anything in previous lesson. Um, um, what does it mean that you can't do anything? So it means that you don't have enough knowledge, or tasks are not clearly defined. Maybe there is something else. Oh, okay, makes sense, makes sense. All right, then let me share the screen and let me describe you that. Okay. And I think that you as a job is totally fine. It's fine, so don't worry about these things. Okay, let me share the screen. Can you see, guys, my Windows system? Mm-hmm. Okay. Um, so um, so yesterday, oh, yeah, no, not yesterday, but on Tuesday, because yesterday I had to run um the regular, well, kind of not really expected, but kind of basic classes at my university. So yeah, so that's why we had to pull classes from Wednesday to Tuesday. Okay, so what the Tuesday was about? So we were working on a Java Swing technology. So what was that? So maybe you remember from the previous week, we were trying to, in the end of the week, trying to analyze visuals so they can be created, what elements we can use, and in the very end of previous week classes, we tried to create a form with three buttons on it, right? And okay, maybe some of you were successful, some of you guys were not successful. But on Tuesday we continued overlooking elements. So you can take a look on this presentation, how you can make these things, and you can follow several of links. Maybe um, I will disable the editing because otherwise I cannot select things. For example, this link is very, very good. You can go through that. You can pick whatever element you like. For example, I don't know, for example, a J button. You can find out some examples how that works, right? Well, literally, there are mostly several examples or for each of the elements. So you can take that and you can use that. And on a Tuesday, um, I asked I asked students to create three projects. Actually, they're not complicated, but since you guys are just starting these things, so maybe you need the time to maybe analyze how you can make this stuff. Maybe go through code examples and so on and so on. But in the end, there had to be a tic-tac game. Well, I suppose everyone knows that tic-tac game. It's a three by three field where you put or where the first player puts X, another puts O, and that one wins who collect um, three crosses or three O's, depending on which player is that in the row, in the column, or in diagonal. Okay, so that was this one. Next, it was the calculator. Okay, about the calculator. Um, I would say this task maybe was not super successful for most of students, but anyway, somehow that works. And the phone book, which literally means that you have the name and, for example, a phone number of the person. You just use the interface to fill the array with data. Then you edit that array with data with some corrections, and you erase records. So literally, in this case, it's kind of using the interface, using the Swing technology of Java. You just manipulate with data of the array. So literally, that was those things which we were working on Tuesday. So Benes, is that clear what we were about to do? Mm-hmm. Okay, great. All right. Yeah. By the way, I uploaded even one another material about the Swing technology, because I was looking for some kind of developer's book, and I figure out that there is in the free access such thing available. I'm not pretty sure if I had to put a link or I had to upload the file, which way is better. But as I was overlooking this material, here you can find out again a tons of examples. Okay, this one is pretty huge one, like more than 900 pages. But anyways, if you would just scroll that, you'll find out a lot of interesting materials. Oh, okay. The interface which we're already familiar with, if you remember, right? Most of you guys, I mean those who were on a Tuesday, most of you used even such, well, exactly such interface for the TikTok game, right? Um, okay. Also, you can find out really a lot of useful materials here. Yeah. So anyways, so if you will need that, you can use that. Okay. So I was preparing um a variety of materials for today, but in the end, I figure out that unfortunately, the community edition will not hold those sections. So we will be trying to get maybe how neural network works in this case, and we will be trying to analyze even the project I uploaded, right? So yeah, um, and then I will define you as small tasks about these things. All right. Maybe let's try to get the neural networks, how they're working, and let's maybe take a look on the project. Let's analyze how that works. And it might happen that I will ask you even to create two small projects. Well, maybe I will just maybe I will just create already of two sections. Okay, give me a second, please. All right, that's the PDF. If okay, yes, project 1 and project 2. Okay, so I will just create them. So those will be things I will be expecting from you. Let's call it one neuron model. Oops. It will be the first one, and then there will be two neuron models. Oh, sorry, two neuron model. Which you will have to implement, and it doesn't really matter if that happens in the terminal or you somehow will show that in the Swing technology. No big difference. Okay, and maybe I will move this material somewhere here next to the Swing, as well as links will be just pulled more close to this one. Okay. So let's maybe try to get what is it, and it's just a presentation which I showed in a couple of places, so that's why it looks pretty different, because I mostly like I mostly use just black text on a white background. Here, since it was a presentation for different places, then it's a bit different. A bit different. Okay, but first I would like to ask you guys, if some of you are familiar with neural networks. Maybe some of you did some projects, some research on that. Sounds difficult. Well, this, I really hope after this, okay, guys, for sure you can hear about a lot of things like Chat GPT. Well, I know that Laurinus uses Chat GPT frequently. I saw that on the screen. And I know that maybe some of you used such thing as Midjourney for generating images. Maybe some of you used websites which um, which use neural networks to color black-white images. So all these things are available. Actually, a vast of such things are available nowadays. And I would rather say it's not really complicated. It's just a matter of how you make the neural network. And today we will make a first step. Okay, so okay, the comment is, yeah, almost everyone uses AI to some extent. Well, I would say yes and no, because unfortunately you cannot use AI to generate, for example, the Photoshop file which you can edit. So unfortunately, the thing is that you can ask neural network to create some image, but unfortunately, that will be the canvas you with pixels you can just modify, and that's it. Oh, well, it might be that it will be available soon. Who knows? Maybe you could try to make one. Why not? Okay, so anyways, maybe after this presentation, I will upload another one, um, uh, in which I will show you how you can use these things for one spatial task. Because again, I have some materials, but I was preparing things which unfortunately doesn't fit that community version. So yeah, so that's why we'll be working on this one. Okay, so literally I will start this topic maybe from a so-called Adam and Eve. So from the very far away ideas from the practicals of neural network. Well, here we have a small content of this presentation. So firstly, we'll talk about neural networks. Then we will try to get such thing as neural networks memory or genetic algorithms. And then we will try to think of how is it possible to use these things in the practical way. Literally, it's an NPC agents approach. If you remember, guys, in the class, when we had classes in the class in Utonas Collegium, I showed you, or maybe it was online, I don't remember. If I'm not mistaken, it was in the class. I showed you the project where those green NPCs, they were moving, they were hunting for the red food items. So literally that's implementable. Okay, so okay, the description is very simple, so we will analyze how these things work, what is it, the neural network, what is the basic idea of that, and so on and so on. So let's start with the neural network. And in this case, I will be starting this topic from not from the technical part, but from so-called real life examples. Actually, this presentation is compilation from a lot of materials. So it might happen that you have seen some pictures from this presentation on the network. It might happen. So yeah. So the life example. I suppose this life example will be pretty clear. So how it happens when, for example, we meet some new people, we try to communicate with them, we try to deal with them, and from time to time we make assumptions in our minds that those people are fine are not really fine for us, and nextly we make decisions which lead us um, to spatial narrative, how those people, for example, would fit in our lives, right? Literally, if we will try to make a simplification of such model, which we have here, which is kind of one of maybe full models or whatever, we can find out such very simplified ideas. So if we have couple of parameters of the person, and by them we would make a decision of the person, we would be definitely pulling a level of importance for every of those parameters. If we would be talking about people, it could be talkativeness, it could be charisma, it could be whatever else. And definitely based on some of those parameters, well, mostly we don't analyze these things, but literally, we have something like, let's call it a function, which literally leads us to a conclusion about the person in the narrative of something. For example, if we would try to take a look on such picture, then it could be, for example, falling in love, cooperation, traveling with someone. So literally we can say and we can predict, or we can make a conclusion if that person would be good or bad for us in some of these narratives. Well, let's make a sort of terminus in this case. So let's say a parameters which we try to include into this so-called analysis or conclusion making, let's call them as input values, and the level of importance, let's call them the weight of parameter. So literally, how strictly we value one or another parameter. Okay, so when we make the model and when we assume the model of the previous slide, we literally can create a so-called a conclusion table or a result possibilities plot in which you would be making the following. So according to the function result, and the uh, developed by well mostly by us when we make the neural network, we literally can say, okay, according to the parameters, the result will be in one area or in another area, well, depending on parameter values. If we call them x, y, then for each x and y, we have a specific result, and this result is placed in such plot. So we actually have this prediction model even. But the question for you guys, so here we have a line, right? Which literally splits or one result from another result. But how do you think that? Uh, but how do you think does it happen in a such way in the life when we have a strict separation? No. Yes. So that's really correct answer. No, it doesn't happen that way. So, and we are not really strict in our decisions, in our conclusions about people, about some events happening, about, well, whatever. We're not super strict. Well, we can be, but in most of the cases, such doesn't happen. So, which means that the function which gave us like here I suppose you understood. Here we have the step function, which means we receive the one result or another result, like the false and true, like a 0 and 1. So it doesn't happen in the life. So let's make a step forward and let's try to think how such model, how such make a like conclusion can be more close to the real cases of the life. Well, all this is related to the function to the function's definition. So if we would have a step function, well, in which we have something like the threshold of the values given to the function, we receive the strict results, yes and no. But in most of the cases, we use such thing as so-called the wise neuron. And the wise neurons idea is that we can be more um, for one conclusion rather than for another one. And in this case, we can literally say, okay, the story could be that okay, we would be more close to the neural neutral conclusion about the person, or we could be more falling in love, for example, with the person, and so on and so on. And literally, that result, it it will be changeable, through time. And I suppose, even in life examples, when you meet someone, when you um um let's say um fall into something with someone, it happens step by step and and by some small changes um, in the narrative of the speaking, in the narrative of actions, and so on and so on. So it doesn't happen like the switch, um, which is provided by the step function. Okay, and by that we have some kind of border area which is somewhere here for the wise neurons case, and we have this areas, which again you see they're not really colored by the solid color, which means that we can be more close or more far away from the strict filling of which are placed in these corners, and so on and so on. I suppose this is understandable. And if that's understandable for you guys, then it will be no any single problem, guys, to understand how the neural network works. Okay, so what will be the next line? The next line, as you understand, we have to use a variety of parameters. For example, the person, since we have this story about the person, to analyze more narratives than it could be, right? So, for example, a cooperation. Okay, in the cooperation, what we need to take into account. For example, again, it could be charisma, it could be talkativeness, it could be how the person, for example, deals with money. And again, depending on the narrative, what we're about to analyze, what we're about to conclude, the level of importance of each of these parameters, it could be different. So yeah, so for example, like even here it's written, right? So because again, life examples. So if something is not really dealing with money, okay, so okay, well, how you can cooperate with that one, or let's suppose if that parameter is not really valuable for you, but again it always is only about you, because these levels of importances, right, they are included in the neural network kind of in the hard-coded way, if we can say like that. So all of these parameters, they have the level of importance, and the level of importance is again that parameter. And again, like in the live examples, in the live case, our attitude against all of those parameters, well, it's changeable, really changeable. And that's what happens in such cases, and that's what happens in the neural networks. Because literally, what we are all looking at here, besides all of these things, like we have charisma, talkativeness, we conclude about cooperation, about falling in love with someone. All this actually is the neural network, by the way. Okay, so that's the idea. And in the end, based on the making conclusions, narratives, right, of life cases, we can make the final conclusion about doing something. And when we have the final conclusion, well, we need to literally is about getting into some event. Well, for example, getting married. So again, for the getting married, you cannot be well more yes. Mostly, it's really strict yes or no question, right? So literally based on the level of that conclusion which we're about to do, we are choosing a function which is gonna be used for making that conclusion. And it's really up to us to provide that as developers of the neural network. So yeah, so that's the idea. That's the basic idea. Um, guys, are we good so far? Is this understandable for us? I really hope these life examples are clear for everyone, But if we have some misunderstandings, if something is not really clear, you can always write your questions in the chat. But I suppose, that a material about neural networks cannot be easier than this one to understand. So the next step, which we would need to analyze is maybe, okay, all this is good, but all this is good, just talking about this. Okay, sounds great. So how technically that happens? So let's say we'll be looking at the function. Let's say we have some function, this one or this one, it doesn't really matter. So the function has its inputs and the outputs. Input is the argument which is received by the function, and the output is the result of the function. So in most of the cases, developers of neural networks, they are predicting that the result of the neuron will be in a specific range of values. For example, from 0 to 1, or from -1 to +1. Well, actually, it's up to you to choose such a region of data. Okay, let's maybe try to get what is it and how is it possible to have the argument of the function. So let's suppose we have three parameters. Now we're talking about them only in the aspect of the numbers. Each of them will be the number. In the same case as we had here, we can even value the parameter even of the person. For example, between 0 and 1. For example, for talkativeness. For example, a 0. Well, it might be the total introvert who is not willing to talk at all. Or it will be 1, which is, for example, the extrovert who is willing to talk all the time. Well, that could be one of examples. So, what we do? We have the level of importances for each of the parameters, and we construct the input value for the function. And you see, based on this, weights, we can maximally have such proportions for the number which will be given to the function. Surely it will be even dependent on the value of the parameter, but here we have the maximal kind of pieces of that value. I suppose that's understandable. Okay, let's make a step forward and let's try to maybe name those things like input, weight, the neurons input, the neurons output. So if we have the following cases as weight 1 is 40% and weight 2 is 70%, and equally we have I1 value, parameter value equal to 1, and second parameter is equal to 0, then how we can construct the value, how we can find out the value which will be given to the function. Well, it will be given in such manner. So what we do, we make a summation of multiplications between input and the weight. In other words, parameter and level of importance. And then that summated value, it will be given as the argument for the function. And then we receive the result. And that result could be another neuron's input value. Is it clear about these technicals? Okay, so let's make a step forward, And let's see the case. Actually, here I don't put you a huge theory. I just want to show you how one neuron works, um, applying a so-called the backwards propagation method for teaching the neuron. And teaching the neuron literally changing by the teaching of the neuron, we literally change values of the weights. So let's imagine we have one neuron. And by the way, you will have to do this in Java. Here we have the code in Pascal. So what do we have here? Well, the narrative of the story is that we have the neuron, and this neuron has to be working in the manner that it receives x1 and x2. Um, it and the neuron has to give you the square of the sum of these two inputs. So some of you might say, well, use the that, but here we use exactly the neurons for this case, because we can train the neuron to work in a specific manner. And literally, sometimes we have only neuron constructions which we can use, for example, within some physical schemes. I mean, micro schemes. It's not always possible to just use the regular ones, which allows to make computations, because neural networks and neurons, they are always about a so-called imitational model, right? So we would like to teach this neuron to take x1 and x2 and give that summations square. So what do we use? Well, we can use the constant, which will be used for memorizing some changes. We will be saying that, okay, by default we have some values for the weights, because they must be, and we can, for example, use a so-called the first time usage input values. We can construct the summated value, which will be given to the neuron, and we can calculate the value which we are receiving from the neuron. Literally, that's the neuron result. So nextly, we have a DF. Well, a DF is kind of expected result. But in this case, to launch the process based on a difference between expectation and result, we need to give some a priori incorrect value for the expected result, and then we use the while loop, which literally teaches the neuron. But how it teaches? It teaches the neuron until the case when during teaching process, we will receive the error between expectation and the real result less or equal than this value. But when it's the opposite case, when it's bigger than this mistake, then we continue to run this teaching process. So during each iteration, we randomize, so we use, we just use another random values from 1 to 10, for example. So if we teach our neuron on the values of 1 from 1 to 10, we expect to use that only in the range of these values. So nextly, we calculate what should be the expected result. That goes to DF. And in S it goes the argument for the neuron. Next we calculate the result of the neuron, and we're about to manage those weights. How it goes? Well, we create the sigma, well, here we have equation. Well, it might happen that this equation is not really clear, but actually it's the real result minus expectation multiplied with um, um, okay, well, with the derivative of the neuron function. I suppose you know what those derivatives are. Do we know what the derivative is? Yes or no? Did you have mathematical classes about derivatives? Oh, okay. So give me a second. I will give you equations for the for finding out derivatives. Okay, so I got the link, and I will give you that link in the chat. And I will open this link in the Windows system. So I will give you some comments about this. So idea is very simple. If you have the function, you can find out derivative of the function. Literally, if you're using some simplified function like the sinus, you can find out its derivative, which is cosinus. So derivative is the function which literally answers the question how the function results changes when we change the argument value. So you can use the simplified functions like you have here, and you can have their derivatives in here. Literally, you can use it. Okay, let's return to the presentation. So we use that, and then literally that sigma is responsible for how strictly, how fastly we have to change the weight based on the input. So nextly we use a difference for the weight, which is minus this teaching factor multiplied with the sigma multiplied with the input value which was given during this teaching process, this teaching iteration, and then we add the result of that to the weight, and that happens for every of these weights, and then we just do that in the loop, since that's the end of the while. And afterwards, we can just, give values of x1 and x2, and we can calculate the result of the neuron. And that has to be pretty close to the real result. So guys, are we good with this example? Okay, so this is the first thing I would like to ask you to implement, but do that for sure in Java. You can use terminal if you like. It's not necessary to use the swing technology for showing something, but if you like, you can. It's not mandatory. So please, guys, try to make implementation of such neuron with the narrative of that in Java. Yeah, sure. Okay, I will do that in the. Okay, I will do that maybe in the middle then. So Um, edit settings. Okay. Well, as you understand, is about to give is what do we expect from that, right? But there are weights which are used for this process, and exactly weights should be corrected during the teaching process to have approximately such result. Is the definition okay for you guys? Is it understandable fully? Mm-hmm. Okay, then please try to implement one. And once there will be some issues or some places in the code in the way you will be stuck, then please tell me, and we will somehow fix the problem. Okay, so please start making this solution. And after some short time, I will be asking you about your progress if you have something to show. Okay, so guys, please please start working on this. All right. So I see that Faustino's uploaded a phone book with edit function. Okay, that's great. I will check that. And is it all right if Laurinus will be continue working on phone book task? Okay, but Laurinus, I would like to highlight that even all of these tasks they will have to be done as well. You understand this, right? Okay, so if that's clear for you and you're willing to continue working on phone book, okay, you can, if you like to do that. Okay, so I see that Alena made the things. Okay, so let's take a look what we have there. Oh, even more than one person did that. Oh, okay. So Faustina's made and Rasa. Okay, well, let's start with Alena then. No, that's made incorrectly because you have to train it. So you have the exact result which you would like to receive, right? But we're not using mathematical apparatus. We're not using mathematical equations for that. We need to make neuron to work in that way. So this is incorrectly. Actually, again, you can take a look on how it was implemented in Pascal. Well, this is the Pascal syntax. But I suppose if you know one programming language, you understand how it works in another programming language. So what you did, you implemented these ones. So you created like x1, x2. You literally said that okay, you'll have x1 plus x2, so without even weights, and you just made the power of that. That's it. So literally, you can see what is missing, like what part of implementation is missing. I don't know. Does it make sense? Okay. So I see from Faustina, so there didn't need manual input. You can use manual input when you already tried, when you already trained the network. If you did that, you already can use the manual input given those values to the neuron. But before that, it's useless because neuron weights are not balanced for your task. Only when they will be balanced, only then it's reasonable to do that. All right. Let me check what others have. Oh, sorry for that, guys. I know that it's pretty different from what we previously did, because it's like we train something, but it's another classical task, which is implementable, I would say, in a lot of programming languages. Okay, so firstly, maybe I will take a look on the code. Okay, so you create a neuron. Okay, you have it. Calculate what it means. Okay, you give values, you give bias, but in the beginning, let bias be 0, and you give the square. Okay, so what you do? Um, hmm. So the first of all, okay, if your weights would be trained, if they would, well, initially you have to set them up, right? That's the first thing. Okay, you can take that from the terminal. You can take these parts from terminal, but about these values, it's reasonable to take them and to give for calculation only when weights are balanced. So you need to have the train function that would train your that will train your neuron for this. Okay, does it make a sense? Okay, now we uploaded normal code. Okay, let me re-download that. Okay, you create the neuron. You made the input and you can calculate. Okay, great, but listen, you set up the weights on your own, but it's not what is going on regularly. The training process should balance them. You cannot just set them up. I mean, you can set them up from the beginning, but they have to be balanced afterwards. And the setting them up regularly is happening using some randomizer. For example, let's imagine the case when our parameters are properties of the person, and your neuron will give you, for example, a conclusion if the person is good for, I don't know, um, for cooperation, for example, or for traveling. And when you set these things up, actually you select the preferences. Okay, that would be awesome. But in the same time, what is good here? The good here is that we can give a priori known inputs and the outputs, right? And based on them, based on the vast of such values, the neurons can be balanced and will be balanced. And in the end, based on your beginning preferences and based on the, let's call that, experience of the neural network, your neural network will nicely make conclusions about input values, about parameters, for example, of people. Who is good and who is bad, for example, for traveling, for cooperation, well, something like that. Does it make a sense? Mm-hmm. So initial preferences are good. You can set them up, but mostly again, a randomizer is used for these purposes. Okay, so we had the code from Rasa, so I will take that. I will try. Okay, here we have the same story. How it happens that Rasa has the same codes? I mean, even inputs are the same. Faustinus, is Rasa somewhere around you? From site. So you took a look on some website, right? Okay, give me a link of that then. Where you took this from? Oh my goodness, GTP, GPT. Well, well. Okay. So what did you ask the GPT? What was your quote you gave? Yes, and it created you the neuron, but you have to have the neuron and its training process. Its training, well, how to say that algorithm, for example. Okay, but somehow you received this code, right? Okay, are you guys sitting somehow together, like maybe you're sharing with the ideas, or everyone just in its own location? Because that's a bit strange. Like Faustinus, you didn't ask, but you have the same code as received from Rasa. So okay, it doesn't make the sense for me, but okay. Um, because okay, it's the neuron. Yes, it's correctly, but in the same time, there is no teaching procedure. Okay. Anyways. I suppose I need to. Oh, wait a bit. What do we have? Requested file could not be found. How that could be possible? Okay. It was erased. Okay. Okay. Understood. So again, guys, you have the codes. You just need to rewrite them in Java, actually. Well, related to the namings, integer is integer, extended is kind of double value. So is it clear what you have to do? Because if it's not, then please tell that openly or write that openly. Okay, guys. So I suppose that means we all are good. So then just keep working on this.
You are currently the only person in this conference.
Guys, do you still see my screen sharing? Oh, okay, on my side it was disabled somehow. Oh, okay. Again, that's pretty weird. That's pretty weird. I suppose that happens because I use that Mac OS. I mean the Apple computer screen, which is really huge by amount of pixels. Um. Okay. Oh wait a bit. What did I open? Which screen do I share? Okay, looks like correct one. Yes. I suppose that the server cannot hold probably this traffic and then it disconnects me. Okay, anyways, please continue be working. Once you have something to show me, please upload the things and let me know in the chat. And try not to ask a chat GPT about the solution, but please try to make it on your own. I understand that asking ChatGPT is kind of good and nowadays feature, but let's try to make implementation on your own, like how to say like it happened in the old good times. Oh, guys, I see it by the timetable. So we're taking 10 minutes break, and after that we will continue working. Okay, so see you guys after the 10 minutes break.
Микрофоны.
All right, guys. So it looks like the break is over. All right. So maybe you can put a plus who is really here. And I see that Gediminas connected. Hello. Uh, if I'm not mistaken, I haven't seen you previously connected. I really hope that you were looking at those classes recordings when they were available. Okay, since it might happen that some of you try to make implementation maybe during the break or maybe just before the break, so I will check what is going on here. Oh, okay. So one of you took out if I'm not mistaken, it was Faustina's probably. Yeah, took out the project. Okay. Um, all right. So guys, the question is, um, well, what do you think about this task? Is it complicated? Because literally, if literally, I remember when I gave the codes in Python as example, you guys, at least some of you, were just rewriting them in Java, and it was fine. So what happens this time? Okay, another programming language, but I suppose I described you the logics fully. So what is that point, or what exactly makes this thing, this time, complicated? Um, hmm, since that's new, right? Okay. Um, all right, all right, all right, all right. So would you like to make this one together? Because I can show you how I would do that. Yeah, the only thing I really hope that you will make solutions afterwards on your own and you will submit them. Okay. Give me a few seconds, please. All right. So yeah. So what I will be doing? Well, I will be maybe. I don't even know. Maybe we can modify the current code. Well, yes, maybe I will just make corrections in the current one. All right, so we have the neuron itself. Well, I would rather say that we could use the randomizer. So for that one, I would make the random RD equal to new random. Surely we would need to have the class used. Okay, so I'm importing the class. Give me a second. Oh, 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 oh. I'm in another IntelliGI. Okay, yeah. Okay, so yeah, so I'm back in this correct one. So it was just open through the macOS, but the Windows is shared. Yes. So now I'm in correct one. So here what we do, we use RD, then we take the next double value. Okay. We copy that and we put it here as well. So that's what we can start with. The next one. Well, we have to be able to get till this robot till this weight, or maybe we can just create the public function which would be running the teaching process. Okay, let's just call that teaching. That will be enough. Fine. So here we need what to do. Here we will need to use probably a do while things, but I would rather use two parameters like result and maybe kind of expected result and real result. Okay, from the beginning, I will set up some nonsense values, so they would be really different ones, right? And then I will be using, for example, a do while. Which will be working till the case when I have the following case. So a difference, the ABS means the absolute value, means without the sign. So when such condition will be correct, it will mean that the error or a difference between expected result and the real result is bigger than such assumed error. So when it's bigger than this error, then we need to recalculate. When it's approximately such big or less, then it's fine. So I will be using probably ABS. And here we'll be using ER minus RR, which means expected result minus the real result. And when it's bigger than, okay, how many zeros did they have? Okay, 3 zeros after the point. Okay, so 3 zeros 1. So when it's so, then we are launching stuff. So what else I will be making? I will be using randomized values, so I need to have the randomizer. And right now I will be having inputs. For inputs I will need again double values. Let's call it x1 and x2. Actually, I can even forget about maybe making values for all of these variables. Okay, and now I will be just making the values. If I would like to have it, for example, between maybe 0 and 10. Well, let's say then we need to say we are working on 11 values from the 0, which means from 0 to 10, and that goes for both of the input values. I suppose we understand this. Okay, why do we have this one here? Might not be initiated. Okay, let it be so. Nextly, we can have expected result, and expected result is the math point poll. And here we will have x1 plus x2. So that's expected result, how the neuron has to be working. So we need to have the argument of the function. Let's say it will be value of s, and it will be weight 1 multiplied with x1 plus weight 2 multiplied with x2. Okay. Next, the real result will be. Oh, actually, we can even use the calculate function. Yes, we can even use just a calculate function. So this point calculate, and we can just give x1 and x2 values. That's it. So this variable s is not even needed, since we have this function. Okay, that looks great. That looks great. And then already we have to implement the editing of the weights. So we need to have the memorizing coefficient, which will have, for example, 7 zeros after the point. So let's make it. All right. And we will have sigma, and we will have dv1, and we will have dv2. Okay, so let's calculate that influence on the weights. So it will be a difference between expectation and the real result, in a way that we take real result and we take out expected result. And we multiply that by derivative of the function. Since we have kind of s squared, then it will be 2s as the derivative of the function. So sigma will become a difference between real result and expected result multiplied by 2.0 multiplied with well, we still need to have this as variable. Yes, because it will be involved. It will be involved in this derivative, because that derivative will be calculated using how to call that, using the real values which will be given to the function. Yes. So yeah, so we will need that anyways. Yeah. Okay, so we will have it, and next we can calculate how we are gonna change the first weights, which is actually memorizing coefficient multiplied by the sigma and multiplied by the input which was given for that weight. So it will be x1. Same it will be happening for the second weights, and then we need just to add to the weight 1 dv1, so which is the weights plus equal dv1, and the same for the second weights. Okay, and already after this one, we are capable to after running the teaching method, we can take some inputs and we can calculate the result. So let's take the neuron and let's run the teaching function like this one, and let's then run it. Surely execution will need some time. Oh, okay. So what do we have? We have some really incorrect data. Okay, it might happen, guys, that somehow zero value would be influencing the result. So let's say we are not given 0 as the input. Right, let's wait. So right now, as you understand, the teaching procedure happens. So we just need to wait a bit until the teaching process will be finished. Okay, so looks like it's still working. We can literally maybe we can lower the error. Maybe till this one. Let's just make it faster to be executed. Okay, actually, I think we can even maybe try to maybe make some outputs at least to get that things are working. Okay, let's see if that process works. And if we have some changes in time. Oh, okay. So I will need to add ln for the new line then. Okay, maybe I can even take a look what are those values of x1 and x2. If they're given in the correct way. Okay, I suppose we have a lot of varieties, so maybe I will be doing it in a bit different manner. I will change those values to the integers, for example.
Там можно сделать, где while 0,1, можно добавить еще нулей и будет побыстрее.
Ну, не будет быстрее, если мы нули добавим. Почему вы думаете, что оно будет быстрее?
У меня работает.
Так, ну я вот просто на самом деле сейчас не знаю, почему оно у меня не срабатывает. Оно, в принципе, оно должно работать гораздо быстрее, оно должно уже давным-давно было закончиться, на самом деле.
У меня получилось 25.
Да, все правильно, так и должно было быть. Так, но ну подождите, вы запустили вот эту teaching функцию себя?
Да.
Так, запустили. Интересно. Так. И я так думаю, что, может быть, здесь вы просто двойку записали, там, где derivative мы пишем. Потому что тогда у нас будет немножко, ну, неточный расчет. Ну нет, все равно что-то не очень хорошо идет здесь.
У меня тут 2.0. Где вы были поменявшие на двойку.
Так, окей, я просто сейчас не совсем понимаю, где я тут сделал ошибку. Ладно, пришлите свой код, пожалуйста, в чате.
Прислал.
Да, спасибо. Ну, у меня чат на самом деле на другом экране сейчас, поэтому я его вижу. Так, хорошо, я поставлю сейчас здесь ваш код. Ну, конечно, у вас, видите, у вас изначально единицы на weight, поэтому у вас даже, ну, во-первых, у вас нету этой процедуры, она у вас тут не запущена, да? То есть у вас стичинг, он не запущен даже. То есть это надо было тогда вот так делать. Вот. Ну и плюс, если мы все равно так сделаем, даже если, что у нас будет? У нас будет по 25. А почему? Потому что у нас сразу же искомый результат совпадет с тем, что у нас в нейроне, в этих weights записано. То есть мы, конечно, можем как-то их поменять, вот, скажем, такие значения поставить. У нас тогда уже сразу будет процесс обучения сети работать. Вот. Но вы видите, тут что-то у нас не совпадает. Что-то не срабатывает. Ну вот я сейчас не совсем понимаю, что у нас тут не работает. Потому что все должно работать хорошо. А я минус не поставил. Да, у нас же минуса тут нету. То есть мы в обратную сторону нейрон используем. Да, то есть тут минуса у нас не было. Хорошо, запустим сейчас, посмотрим. Ну вот, видите, да? У нас есть результат. Okay, guys, so you see, right? I didn't put the minus in the position where it had to be, right? And we got totally incorrect results. So that's why we have to be very, very accurate with those signs we're using. Did everyone see where I had a mistake? Well, yes. The minus for changing, well, for the influence for weights, yes. So exactly in this place. So as you can see, small tiny mistake, and you already receive incorrect results. And now actually, as you understand, we can give whatever values here between 1 and 1 and 10, since we're working between these values, and we will receive results. For example, 9 square is 81, so we have to receive the value around 81. Yes, so you see, it's not exactly the 91, but it's somewhat really close to that. If we would like to have closer values, then we need to lower that allowed mistake. For example, I lowered that for 2 orders, and let's see what we'll receive in this case. Will the value be closer to the real result? So you see it's closer now, right? So it's 978 and after the point. If I'm lowering that error more, more influence in that, then it takes more time for teaching process, but it's more and more close to the real solution. Does it make sense, guys? Why this error is a variable? Does it make a sense? Okay, okay. So now you know how you can modify your codes. Okay. So definitely you will need to finalize maybe your solutions. Try not to take the code of your colleague. Try not to take the code from the Oswalders. Yeah, and definitely we will have the second program, the second code, which is this one. And I really hope that you will implement this on your own. So here we have the following. So we have input value, and the narrative of these neurons is that in the end here, right, we have to receive x1 in the power of 4. So it means each neuron's function you pulls the argument in the second order. So which means that that we take the value, we put that in the order of the, sorry, in the power of the 4, that's the result. And as you can see, for each of the neurons, we are powering that in the second order. So 2 times in the second order means the original value into order number 4. So you have all of these codes, you have the example I showed you. So please guys, try to maybe modify that code, or maybe try to make it on your own, and that will be the solution for that second, well, for the 2 neuron model. So please try it on your own. And if there are some okay, if you might go after the lesson, okay, you can, because things to do could be pretty different. Maybe something is really how to say really serious, so you can, not a problem. But things related to this task, to the task of 2 neurons connected between themselves. Is it clear for us right now what we have to do, and at least approximately how we have to do that? So yes or no? Or maybe is it more yes than no? Okay, for Fastinos it's clear. Okay, great. What's about others? Okay, guys. So please try this. Surely, if it will be problematic. Oh, okay. So we would like a definition of the second task. The full definition. Okay. Implement in Java 2 for one input model where parents are about to give x1 in the fourth order. Well, I suppose it will be understandable. I mean, this definition. Okay, so I suppose that will be fine. Okay, so since there are no questions in the chat, I suppose the story is clear what we are doing. Okay, so guys, please try to make this model, and uh, and if it will be let's say not really, if you will be not really successful with that, it's fine. We can do that afterwards together. I can show you how to make one. But first, let's try to make it on your own. So guys, do we have any progress? Oh, you need some more time, maybe. Okay, some more time, I understood. Okay, so keep working. Keep working. Okay, Faustina, so you get the results. Okay, maybe you can upload the project so I can take a look on. Faustinas, did you make the upload of the project? No, you didn't. So well, but wait a bit. The story is about the second project, right? Is it? Because as far as I see, well, there is nothing. Or maybe you're talking about the first one. So it's about the first one, right? Okay. Okay. Mm-hmm. All right. So this is what you have. You have neuron, you have calculate, you have the teaching process. Yes, you will get the weird results because here, as you can see, as I talked previously, we have to have the minus sign, right? That's the first thing. Okay, and now let's run it and let's see what we will have here. Okay, we have no idea what are those inputs you're using here. So let's just use some numbers. You know, like I don't know, 3 and 4, which will be 7. So 7 in the second order is 49. So let's run it. Okay, it's okay. It's not really close, so maybe we can reduce the allowed error we can have, and we can run that again. Yeah, so you see, the approximate result is there. So is it clear where you had the problem? Mm-hmm. Okay, great. And then when you will change that and you will resubmit the project, you can start making that second model, which contains 2 neurons. Okay, do we have anyone who would like to share the 2 neuron model? Да, у Сольдоса могу сказать по-русски. Если у вас есть какие-то результаты насчет второго проекта, вы можете их, ну, во-первых, вы можете проект отправить в Moodle и сказать, что вы его отправили в Moodle. Тогда мы можем с вами вместе посмотреть ваш проект. Ну, или если у вас есть какой-то прогресс, вы хотите обсудить, вы можете тоже, скажем, сказать через микрофон или в чате написать. Ну, если вы хотите коды присылать, вы можете private чат открыть, и даже там вы можете коды отправить. Вот, ну, как-то так. То есть, если у вас есть что-то, что вы хотите обсудить, ну, да, по второму вот этому мелкому проекту, где 2 нейрона, тогда смело говорите, будем обсуждать.
Я там отправил проект, я не знаю,
Сейчас посмотрим. Сейчас посмотрим, что у вас там получилось. Я надеюсь, этот код не был сделан через чат GPT.
Нет.
Хорошо, хорошо. Так, ну что у нас тут есть? У нас есть print output, хорошо, здесь у нас есть калькуляция output, инициализация весов, окей, input, окей, у нас есть. Мы создали модели, мы сделали input. Ну, как бы input он нам, ну, здесь он не особо нужен, потому что нам сначала надо модель протренировать, чтобы, во-первых, ну, во-первых, вообще эти веса у нас они были скорректированы, потому что изначально, ну что у вас, изначально вы сами добавили значение и все, но они нигде не корректируются здесь. То есть если мы запустим вашу программу, ну что мы увидим? Давайте посмотрим. Ну да, выход с первого нейрона, выход со второго нейрона. Но по факту у вас, как вы понимаете, если вы даете input 2, то у вас 2 должно быть в четвертой степени. Это 16. То есть, ну, вы видите, что у вас нейронная сеть не дает ответ 16. Ну, или около 16. Нету такого результата у нас. Поэтому вам необходим процесс обучения сети. То есть, ну вот что-то наподобие той функции teaching, которую я делал для одного нейрона. Но в данном случае этот процесс, если мы посмотрим на вот этот вот код, он в себя включает расчет для двух нейронов. Как вы видите, у нас один дериватив используется и второй дериватив используется. Понимаете, о чем речь, да?
Да, понимаю.
Мгм. Вот, поэтому я все же рекомендую попробовать переписать вот этот код в функции, ну, допустим, она будет называться также teaching, или, может быть, как-то по-другому хотите назвать, можете это сделать. И ее нужно будет запустить после того, как вы создадите нейрон, ну, вот, соответственно, с теми весами, которые вы делаете. Ну, еще раз посмотрим, что у вас тут есть. Где у вас initiate weights? Neuron model. Ну вот, то есть у вас веса есть, но вам их надо корректировать. Это значит, после вот этой строчки, там, где вы создаете нейрон, вы уже можете запустить процесс или, скажем так, функцию обучения, которую вам еще нужно сделать, кстати. Ну, вот как-то так. Вот такие мои комментарии будут насчет этого кода.
Понятно.
Мгм. Ну, вы не переживайте, вы просто пробуйте сделать. Как я и сказал, но если у нас опять не будет получаться, в этом нет ничего плохого. Я опять покажу, как это можно все сделать. Ну, главное к этому спокойно относиться. Ну что ж, тогда, Освальдс, продолжайте работать над проектом. У нас, насколько я понимаю, еще скоро уже будет перерыв, но ничего, продолжайте работать. Посмотрим, как дальше будут обстоять дела. Okay, guys. So looks like we are moving to the break. All right. So maybe you can just write a couple of words about your progress before we are moving for the break. For sure, if you like. If you don't like to share the info, that's up to you. Okay, that's understandable that it's the second program mostly. All right. So since there are no any other comments, I suppose you just working on these things. All right. So let's take the break. By our schedule today we have 10 minutes break, and then let's have the last class for today after the break. Okay. So see you after the short break. So guys, please continue working, and once you will have some questions, something you would like to share, then just give me know about this. Okay, so I see that Faustina's uploaded that. All right, so let me check what we have there. All right, so it's deactivated, and now I'm gonna open the project. Um, okay, so we have two different neurons. Okay, makes sense. Let's see what we will have in the result. All right, you know that's weird because if you have two, then in power of 4 it has to be 16. And we have 0.6, well, something like that. All right, so where could we have problems? Let's take a look. So we have teaching for the first, teaching for the second. Okay, looks like I understood what's the problem. So if you follow the picture, the question is, do you see any differences in teaching processes here? Well, if you would be accurate with equations, and if you would take a look, you would see that for the second neuron, how the sigma is being calculated. It's a real result minus expected result, which comes for this neuron, right? And for the first one, as it was shown, it was the second neuron's sigma multiplied with the weight. And then it comes that derivative of the function. So it might happen that you can share the sigma and the weight of the second neuron somehow during teaching process. And moreover, if you will take a look, we don't teach each neuron separately. We do that in one shot. So it means the teaching procedure should combine teaching of both neurons simultaneously. And these teaching processes for the first and second neuron, they're connected. Does it make a sense? Okay, so again, please try to go through the codes and make the same. Because I understand you try to do something else, something totally on your own, but firstly, please take a look on equations which are used and try to analyze them. Well, from my perspective, it's really obvious because sigma 2 is here and sigma 2 is here, so somehow these processes are connected for first neuron and second neuron. Well, it's not even needed, guys, to make classes, because you see here, I have the code without any classes. And this code actually works. All right, I hope my comments will help you. So please continue working on it. Okay, Benes, if you need to go, then you can go. But I would like to remind that all of those assignments, they have to be done and they have to be submitted in the end of our these overall classes. Okay, Benes, goodbye.
Не возникла проблема.
Да, так, какая проблема?
Я могу в чат отправить код?
В private чат отправляйте тогда.
Как?
Ну, хорошо, отправьте так, как вы можете. Так, ну, на первый взгляд выглядит приемлемо. Так, хорошо, какая тут проблема есть?
У меня тут проблема с x2, где...
Угу, сейчас посмотрим. Так, x2. Ну, послушайте, у нас, я так понимаю, просто нету x2. Вам его нужно сделать. Вот если мы посмотрим, где у вас x есть, вы видите, у вас только x1. Ну, мы вот сделали x2. И теперь он у вас должен быть, вот, посмотрите, он у вас есть.
Нужно было его...
Нужно было сделать эту переменную. У вас ее не было.
И работай.
Ну, смотрите, ну вот я добавил x2 сюда. Ну, хорошо, ладно, давайте я вот запущу, посмотрим, как у вас оно сейчас работает, не работает, увидим. Так, ну хорошо, у вас результаты, наверное, какие? Ну, print outputs. Ну, а что у нас outputs? У нас весь outputs, это хорошо. А как мы с вами получим, ну, хоть какой-нибудь там, ну, вот расчет хоть какой-нибудь? Ну, давайте мы не просто outputs выведем, да, а мы еще, скажем, сделаем расчет, используя наши вот эти weights и еще функции. Значит, будем делать на самом деле все очень просто. Мы сделаем все то же самое, что у нас здесь есть. Единственное, мы возьмем какой-то конкретный x, ну, не знаю, допустим, двойка, да. 2 в степени 4, это у нас будет что? Это у нас будет 16. Вы согласны, да? Есть такое дело, да? 16 же будет.
Ну да.
Вот. Ну и давайте теперь выведем этот результат. Значит, допустим, что мы сделаем? Мы сделаем x1 плюс, напишем, что вот вторая степень, теперь мы напишем знак равно, и здесь f2 поместим. Ну и давайте теперь запустим этот код и посмотрим, что у нас будет получаться. Так, ну что, есть у нас 16? Ну, в общем-то, есть, потому что значение очень-очень близкое к 16. Если мы хотим еще ближе сделать к реальному значению, ну, мы тогда уменьшим с вами ошибку, которая допустимая. Ну и теперь, если мы это запустим, то что мы получим? Давайте сейчас посмотрим. Видите, мы еще ближе стали к реальному ответу. Ну хорошо, допустим, у нас будет не двойка, ну, к примеру, тройка. Ну, вот 3 в степени 4 это сколько? Это 9 на 9, в общем-то, это будет 81. Ну, давайте посмотрим, какой будет результат. Будет ли это 81? Ну да, 81 почти. Вот. Соответственно, ваша программа сделана правильно, и, в общем-то, она работает так, как нужно. Так что, как видите, у вас все прекрасно, у вас есть результат. Остается только дополнить это, ну, вот примерно таким же кодом, который я сделал, чтобы мы могли дать какое-то первое значение, которое нейронная сеть будет получать, ну и, соответственно, чтобы мы могли результат посмотреть. Ну ладно, я думаю, тут у нас с вами все в порядке. Так, okay, so I will have questions for others. So, guys, how is your progress? Can you already show something working? And like your colleague, if you have some issues, you can always ask. You don't have to be shy about that. So, guys, what is the progress, or you just need some more time? For example, you can overthink the code which is written by Oswaldus, but please don't make copy paste. Just make things on your own. Okay, so since there are no messages in the chat, I suppose that means that we don't have the progress so far, which could be shared. Okay, but guys, Alena, Faustina, Carlos, and Nikita, are you still working on the second task, or you may be stuck somewhere in the middle? Okay, Faustinus, in your case, you have to rewrite that procedure because you have two neurons and they're not working in the similar manner. Okay, they give you the same result according to the input. That's great. That's fine. But the teaching process is just one solid for both of them. Not within each of them separately, but for both of them. So in this case, you can make the function teaching, which includes both of the neurons. Which means the teaching process should not be inside each of the neurons, but it should contain both of those neurons. No, it's not teaching one and teaching two. It should be one teaching process, in which during each data proportion you are given to the neural network, you firstly teach the second neuron and then the first one, and then again the second one and the first one, and so on till the case when you will receive small error between expected results and received results. Is it clear what you have to do? Okay, maybe. um, all right. Anyways, you can spend maybe some 10 minutes trying to do that, and afterwards I can just show you how you can approximately make it. But firstly, try on your own. Okay, so I see that the code is being posted. Let me take a look on it. No, that's not really correct. That's not really correct. Because if you will take a look, Faustinus, on your code, so what you did, um, you have two functions, right? Each of those functions make the power of 2, right? In your case, you wrote power of 4. That's one thing. Another thing, you don't need to um, how can you calculate the function of, and then you write the value into RR1, and then you calculate the same value, write and the result in RR2. I mean, what's the difference? Because you give the same value in well for each of the neurons, but if we follow our such scheme, then the input for the second neuron is the output of the first one. And firstly you calculate sigma 2, and then you calculate sigma 1. An equation, equations are different. In sigma 1 calculation you have sigma 2. Again, please take a look carefully on these codes. You see, sigma 2 is calculated using a difference between the neural network. The neural network, I highlight this phrase, neural network, a real result and expected result. And in a sigma 1, you have sigma 2. You know, Faustinus, it's just a matter of rewriting, that's it. And moreover, in the while condition, you just use the expected result and the real result of the neural network. Well, here, I mean, here we have the neural network which contains of two neurons. So you're comparing only the final result. So only they should be compared. Does it make sense? Okay, well, as I said previously, if still you have problems in the chat, there is code from Oswaldus. You can take a look on that code because it's well, it's written nicely, so you can take a look on how it was organized. And somehow I don't receive anything from Alona, Nikita, and maybe Carlos. Guys, are you working on the project? Yes, also does understand that you posted the project. That's really great. What is about others? Окей. Так, Алена, я понял. Ну хорошо, но я опять же хочу подчеркнуть, что вот в чате есть код, который прислал ваш коллега Solдers, и этот код, ну, он прямо то, что необходимо. То есть вы можете посмотреть на то, как это было все сделано, и, ну, не скопировать, конечно, а можете сделать свой вариант. Ну, плюс, еще к тому же у вас, ну, вот код на Паскале, он весь дан вам. В принципе, вы бы могли просто его переписать только на Java и все, в общем-то. Просто, ну, вот реально код есть. Вот, например, вот когда я давал коды на Python, вот как-то студенты переписывали, с легкостью. Вот, а тут как-то вот странно. Но опять же, хватит только вот даже его переписать, он будет работать, потому что это рабочий код. Ну ладно, в любом случае пробуйте сделать этот код, потому что, ну, надо пробовать. Так, а что у нас у Никиты происходит? Может быть, Никита, вы можете написать хотя бы пару слов. Ну, соответственно, как идет процесс? Okay, then guys, try to be working. Well, I don't know. We don't really have much time, and I don't know. If you don't mind, we can take a look on that presentation till the end, and we can take a look on that project, at least how it was organized from the beginning. And then maybe maybe afterwards you can finish this project till the end, and you can submit them. So let's maybe take a look on the next slides, because I suppose we kind of stuck on these solutions. Так, Алена, что вы имеете в виду под проектной работой? Если вы имеете в виду про самое финальное, то, что требуется, вот где вам презентацию надо сделать, там, где вам надо проект какой-то создать. Как я говорил в самом начале, вы сами придумываете тематику, сами придумываете проблему, которую вы можете решить, и создаете проект и презентацию ее демонстрирующую. Ну, во всяком случае, описывающую полностью. Вот. Но конкретно это просто вот один проект, который мы можем посмотреть, как он был сделан. Вот. Соответственно, тут нет ничего такого уж, ну, с моей точки зрения, сложного. Но просто опыт нужен, чтобы это все делать. Ну и, конечно, так, а есть примеры тем. Ну, на самом деле вы можете абсолютно любое сделать. Окей, это может быть, я не знаю, учет продукции на складе, это может быть, я не знаю, там календарь для приема у парикмахера, к примеру. Ну, что мы можем еще придумать? Ну, не знаю, телефонный справочник там с фотографиями, скажем так. Но главное, чтобы там не было такого, что у вас, я не знаю, 20 строчек кода и на этом все. Но это будет, ну, совсем как бы странно, по меньшей мере. Okay, so I hope I answered, and let's take a look on the presentation. Well, at least we'll finish the presentation then. So what's next? The next subtopic is about genetic algorithms. Well, the story here is super simple. We can imagine whatever parameters, and let's suppose the life examples. We all have some parameters, so we have different hair colors, we have different eye colors, we have different height, and so on and so on. So literally, each of these parameters could be a code, and a bunch of these codes which forms the individual's so-called data set. It can be called as the chromosome. So the chromosome is something like all parameters stored in a container. Okay, and we can say that we can have a lot of such chromosomes. Each of the chromosomes could be individual or a person, if you like to call it that way, and we could have something like a simulation of populations of the chromosomes. Well, mostly in this subject, we have five so-called phases, like initial population, fitness function, selection, crossover, mutation. Literally, you can imagine each of the chromosome as someone, and those someones, they reproduce themselves, they kind of survive, they die, and so on and so on. Literally, we are those who set up the functions for making them survived, making them died, but in the end of okay, not really in that of the generation, but to produce a new generation, what we do, we literally take information, for example, from two of chromosomes, and we somehow um, mix them up, and we create another chromosomes with those parameters. Okay, how it's related to real life? Well, to the real life, it's related by a very simple case when we are looking like our parents, literally. So, um, so if they are parents, so mom and dad, so literally you have something from both of them. Literally the same is how new generation so-called chromosomes are being implemented, are being created. Surely sometimes mutations happen, which means that by the accident, some of the parameters, they're just being, changed in not predicted ways. So it happens chaotically. And, sometimes those mutations, they can be kind of ingrown into the population. It becomes sometimes this way. Sometimes those mutations can make individuals stronger, sometimes weaker. Well, all this depends on environment where we have those chromosomes. Okay, so okay, all this could be looking interesting, but what could be appliances of this? Okay, we understand that NPC is one thing. What else could be? For example, here I have a few slides from another presentation integrated into this one. That when we have a picture on which it's drawn, well, some trajectory is drawn, we can find out by the genetic algorithms, by applying this method, we can find out equations of those lines which are drawn. Surely some of you would say that we can use polynomial calculations, which is mathematically correct, and we can do that, but here we don't really need to know mathematics. So, for example, here we have the line drawn. By the way, it's the real application. I personally wrote this one. So we have the line, and we can make populations of the chromosomes, taken data from this image, and we make, for example, 30 generations of those, and by then we receive parameters of the equation that characterizes this line. All this is doable, all this is 100% possible. Okay, so I'm moving forward, and now it could be the question, well, how it happens that both of these neural networks and genetic algorithms, they could be combined. Well, we can imagine that those parameters we were talking about, they are, well, the first time. So we have reactions of the agents. How those reactions should happen? Well, the agent should be analyzing where is the food located, where other agents are located, what is the current velocity, and what is the angle which should be literally which is right now actually. And all of this data actually, they could be inputs for specific neurons. So here we have 3-layer neurons. Well, surely this this neural network is much bigger than those ones which we're trying to implement today. But anyways, and in the end, we have two neurons on the output layer, and both of those neurons literally say how the agent should be turned. So how it should turn around itself, and what should be the current velocity of that, of the agent to survive. Okay, but the question to survive or not to survive, well, how we can tell that? Well, all this is doable, all this is reachable by just, teaching the neural network, right? And we can make an assumption that each of these connections between neurons, because they have weights, it's a kind of a knowledge. We can call it that way. So if that's the knowledge, we can say that's the parameter. So in the end, if we have the neural network, we literally can save all of those weights as the chromosomes data, and then they can be, reproducing some new generations, like what happens here, or there could be mutations happening. So all this is doable, all this is implementable. Yeah, so that's the idea. So you see, it's not super complicated. All right. Well, is this one clear for you? I mean, how we can use this, and what are those genetic algorithms actually? Is it clear, at least approximately? So what would you say, guys? Okay, so let's maybe take a look on the project which has such implementation. Surely I showed you that previously. Okay, so it's on the bottom. So we can take one. We can cut this out, put this here. We can extract data. Okay, and I will be opening that project. Okay, so looks like it's downloaded. Well, surely you can find out some even README files here. The only thing, if you will try to download this project from the GitHub, because actually you can find out links, it will not be working. So this project is, well, let's call it modified. Yeah. So here we have a so-called data of neurons, which are shown here. So so this brain is actually kind of pre-computed weights, which can be used, and we have the main, and here we have the neural networks. We can have genetic algorithms and agents. Okay, and we can, oh, wait a bit. What's going on here? Okay, that's a bit weird. So we can have the neural network. We can have the list of the neurons. Okay, I suppose right now it will show me that some GDK is missing. Let's take a look. Okay, what types of problems do we have here? Okay, I'm not really sure why it's not compiling and why it has the problems. Okay, so it tries to be loaded. Okay, let's wait a bit. Okay, while it's happening, we cannot do anything. Okay, let's wait a bit. Okay, I don't know why it's not loading. Okay, maybe we can just analyze probably the codes. Okay, so the population. So literally it's iterable, so it means that it's something similar to the array, and we can go through that. So we can have number of chromosomes. Literally we can have the size of the informational field. Well, if we can call that way. So what do we have nextly? This class actually extends the chromosome, and the chromosome has the following. So it has the list of parameters, so which means that in the population we have a list of the list, so it's two-dimensional array. And even in the theory, even here, I will show you where it was. We have like a two-dimensional arrays, you understand? So literally that's the construction of this. Okay. Yeah, so randomizer is there because sometimes mutations can happen. Sometimes we would like to have initial data, based on the random values. All this is implementable. Well, what else would be interesting? Maybe the fitness function. Okay, not really. Yeah. So for example, evolve function. So how that happens? Well, we get some mutations. We have the crossover. So literally, we have we have children in the population, because you know that population actually is kind of data which will be used by the neural networks. So that would be implementable that way. We have listened that listener, but it's not very interesting. Okay, let's maybe take a look on how those chromosomes are related to neural networks. Well, actually, okay, here we have the neural network. Okay, we can have amount of neurons, and we creating them. Surely, there will be connections between neurons. So what is provided in the neuron? Okay. So we have some parameters. It's understandable. We have signal creation. So literally that means that we give the output. In this case, parameters are those inputs which are readable and writable actually. Okay, so here we have the threshold function. Well, that's literally the implementation of the functions we can use. Okay, so if we have the chromosomes, we have even the neural network. So what the agent consists of? Let's take a look. Well, we have positions, we have angles of rotation, and for each of the agents, we have to have its neural network, which is working for them. Okay, well, maybe I will have to spend a bit of the time to search those connections between elements. Okay, so anyways, maybe when I will have maybe a so-called the map of how all these elements are connected, maybe I will then post that in the Moodle. So, well, to make it a bit easier to find out this. Yeah, and since we are kind of oops, and since we're kind of running out of the time, so yeah, right now I don't think we can finalize overlooking of this one. Okay, but anyways, you know, guys, we still have some days with classes. For example, we have them tomorrow, right? So tomorrow we will be starting with analyzing this. I will try to find out if there is a connection between objects, and if there is no, then I will just try to make that on my own. So it would be even for me a bit easier to scroll through this one. And then tomorrow we will be start analyzing this project, and we will be trying to make some small modifications of that on our own. Will we be good with that? Okay. All right, guys. So then let's finish the classes for today, and tomorrow we will be again working with all this.